Hello everyone. This is a question which appeared in CAT 2000. So you're supposed to find the remainder of this number, which is when divided by 12. So this concept we've discussed in the concept video. So first of all, you find out the remainder when 1421 is divided by 12. So when you do that, you'll find that the remainder is 5. Then you have to find out the remainder when 1423 is divided by 12. Again, like I told you in the concept video, you do not need to divide it again. 1423 is 1421 plus 2. So the remainder will also be 5, that is this 5 plus 2. So this is 7 and this is similarly. So you're adding 4 here. So this is 9. So we need to find out the remainder when 5 into 7 into 9 is divided by 12. So that is 315 divided by 12. So you can, or in fact, let me use another concept here. So we are supposed to do this. So we will cancel out 3 in this case. So we are left with 21 fives, that is 105 divided by 4. The remainder here is 1, and because we cancel out the factor of 3, the remainder remaining is 3. Otherwise we would have had to, like I was trying to do earlier, in fact, I would have gotten this number, then divided by 12 and found the remainder. That is also a perfectly valid way of solving the question. Okay, I'll just give you a quick tip here, although this will be discussed in another video. When you're trying to find out the remainder when you divide by 4, the divisibility test of 4 is that whatever number you have, you take the last 2 digits of the number and see if the last 2 digits, the number formed by the last 2 digits, is divisible by 4. In this case, the last 2 digits form the number 5. 5 is not divisible by 4. The remainder of this number when you divide it by 4 will be the remainder when 5 is divided by 4, which is 1. So you don't need to divide the whole number. In case of 4, just take the last 2 digits. Similarly, in case of 8, let us say I have a number like this. I take the last 3 digits and see what is the remainder when these 3 digits are divided by 8. In this case, again, the remainder will be 1. So this is just another extra concept. Okay, now let's take this example. If you have 2 raised to the power 2004 and we have to find the remainder when that is divided by 7. Now, like I told you in the concept video, you are supposed to try to get this number as some ax plus 1 form, raised to the power whatever, in this case whatever or whatever it is. So you can see that 7 is equal to 8 minus 1, 8 is equal to 2 raised to the power 3. So what we do is we take out the power of 3 here and write it as 3, 8 raised to the power. So this is 2004 divided by 3, right? Because we are trying to get 3 inside. So this is 8 raised to the power 668. Alright. So as you can, I'll just do this again to make sure that you've understood. 2 raised to the power 3 into 668 is equal to 2 raised to the power 2004. So if I'm trying to get this factor out, all I need to do is divide the power with the power that I'm taking out. So 8 is equal to 2 raised to the power 3. I'm taking 3 out of this factor, so I need to divide this by 3, and my answer which is remaining is 668. Now this I can write as 7 plus 1 raised to the power 668. So the remainder in this case is simply 1 raised to the power 668 or 1. Now in this case, if you are very clear, see what you need to see is that you are, again, like I told you, you try to get this number in the form of some factor of this plus or minus 1. Now let's look at this number, this question. Now we have 2 raised to the power 2006 and the same divided by 7. Now you might feel that it's the same thing, I can just get 3 out and I can get it in the same form. But the difference here is that 2004 was divisible by 3. So I could write 2004 as 3 raised to the power 3 into 668, which I can't do here because 2006 is not divisible by 3. So what will happen now is I need to first of all write this so that it becomes, we can get perfect numbers out of it. So what we can do is we know that 2004 is divisible by 3. So I'll write it as 2 raised to the power 2 multiplied by 2 raised to the power 2004. So which is equal to 4 into 2 raised per 2004. Now I just keep 4 out and write this as like I wrote earlier, 2 raised per 3 into 668. So this is 4 into 8 raised per 668, which is 4 into 7 plus 1 raised to the power 668, and now I divide the whole thing by 7. So I keep this number out. So this is the same thing as when I was taking the product. So this is one number and this is another number. Remainder when 4 is divided by 7 is 4, and when this whole thing is divided by 7, the remainder is 1. So the remainder of this entire expression will be this, which is equal to 4. So the remainder in this case is 4. Okay, this question appeared in CAT 2004. So we given this expression 15 raised to the power 23 plus 23 raised to the power 23, and we are asked what is the remainder when this number is divided by 19. So as you can see, this is of the form a raised to the power n plus b raised to the power n. So we know that this will be divisible by a plus b when n is odd. Quick reminder, how do we check this? We just substitute n is equal to 1. N is equal to 1 means that this expression becomes a plus b. So it is divided by a plus b. So when n is odd, this thing will be divisible by a plus b. You can go back to the concept video and remind yourself of this concept. So this means that this expression that we have right here is divisible by 15 plus 23, which is equal to 38. So this expression is divisible by 38. Obviously, when it is divisible by 38, it will be divisible by 19 because 38 is equal to 19 into 2. So this means this whole expression is divisible by 19 as well as by 2. So when I divide this whole thing by 19, my remainder will be equal to 0.